So we're starting chapter 6. This is lesson 6.1, Powers and Exponents. In your notebooks, I want you to do this warm-up right here. So we're going to be labeling the vocabulary, what each part is called. So this part's easy. Who can tell me what that little 2 right there is called? Raising our hands, who can tell me? Let's see, Romario. It's like the times 2, but what is its official name? What's its official name? Let's see, Michelle. It's an exponent. It's easy. We're doing exponents. We're doing all of that powers. You can also call it to the power of 2, but its official name is exponent. This one's a little trickier. What is the name of that big 5? Do we know? Let me see, Miles.
A whole number.
It is a whole number, but in this form, what are we talking about, Romario? It's a 5, but what is its vocabulary, Hannah? Let's see, Lucy. It is the base. So you can remember that it's the base because that's the starting off number. That's the starting off number. Just like when we're doing baseball and you start off at the home. I don't play baseball. But the base is the initial one. We're dealing with that. So I need you guys to write this down. The big number is our base and our small number is our exponent or the power. Now, this is important. Our base is the factor and our exponent is how many times we're going to multiply that factor. So if we had a to the third power, a to the third power, that would be a times a times a 3 times. So it's our factor, how many times? The base is our factor. So Liam said this is an exponent, so we're multiplying by the smaller number. I assume, what do you mean by smaller number?
Like the exponent.
The exponent. We're not multiplying by the smaller number. We're multiplying our base, that bigger number, the amount of times that smaller number is. In your notebooks, I want you to do this warm-up number 2. First off, you're going to solve, and then you're going to tell me what that term is for that for the answer, what the term is. Now, before we begin, I want to point this out. Is this how we do it? No. Notice how if that was how we do it, it'd be really silly to just write it in a different way. Like, it'd be pretty weird. So these are not equivalent. So what is 9 squared? Who can tell me what 9 squared is? I want to see an answer from Trey.
81.
It is 81 because that's 9 times 9. That's supposed to be a 1. It looks like a 1. Okay, now, what is that called? Who can tell me what the vocabulary term for that is?
Answer.
It's not the answer. So what is the name for this? This is interesting. Let's think about it. So power is that 2. It's a good guess, though. Now, I'm going to write... Oh, let's see. Lucy? Let's see. Liam? A whole number. All of these are whole numbers, but we're talking about the vocabulary terms. Do we have anything, Oswaldo? Exponent. Once again, that's what the little 2 is. We're talking about this 81 here. Rocco? Product. It is a product, yes, but specifically in this case. I'm going to go over what it is. Are we ready to see? So, 9 times 9, 81. That number is a perfect square. What's the rule with squares? What's pretty much the one rule with squares, Malia? All sides have to be the same. So this is 9 and 9. Now, what if I was trying to find the area? How would I find the area of the square, Michelle? 9 times 9. So when I make those together, when I multiply those together, I am finding a perfect square. Rocco asked a great question. He says, is it always going to be a perfect square? Yeah, when we're doing our exponents, it's always going to be a perfect square. Let's think about it. 10 times 10. That's going to be 10 squared. What is 10 times 10? Everyone at the same time? 100. If we did this as a square, one side is 10, the other side is 10, and what's our area? Our area is at the same time 100. So notice every time what we are doing is making a perfect square. Yes, Hannah? Hannah is correct. This only happens if our exponent is a 2. If we had it with 10 cubed, let's say, it would be a perfect cube. But we tend not to call things that when we get further. We tend to just deal with perfect squares, especially now. In your notebooks, I want you to write the top one in exponential form and the bottom one in product form. Melanie, how do I write that first one? What do I write? So I write a 4 and I put a 3 on the top. Who agrees? So who disagrees? So we see that. Melanie, I want you to call in a lifeline. Hannah, what did she do wrong?
You have to count the original 3, so it would be 3 to the power of 4.
Exactly. So the initial number, our factor, is our base. That's going to be our big number. And how many times we see it is going to be our exponent, our power, or our little number. Similarly, as we know, if we wrote this in product form, it would be 10 times 10 times 10 times 10 times 10, which some of you acutely told me, thank you, Ben, thank you, several of you, that it is 100,000. Excellent. So, here, the factor. Which one is our base? Which factor is our base, Alinza? Think base, B for bigger number, the bigger sized number, not the bigger number numerically. So which one is our base, Alinza? 4, yes. So our factor, 4, is the base. How many times is it being multiplied, Rafi? How many times is it being multiplied? Emerson, how many times is it being multiplied? 3 times. So the exponent is 3. So it can be written as 4 to the 3rd power, or 4 cubed. Excellent. Now, in your book, go to page 434. You're doing letters A and B. Then you're also going to do just part 1 of C, D, and E. So you don't need to solve just yet. Just write them out. First teacher, Roman, come on up. I want you to write the answer to this, please. So it is 7 to the power of 4. Jasmine, come on up and solve this. Jasmine is right. It is 9 to the power of 7. So Ben is going to solve this one for us.
So like 10 times 10 times 10 times 10, and then it equals 100,000.
Excellent. So he wrote our base, our factor 10. He wrote that out 5 times, and we got the number 100,000. Excellent. Oswaldo is gonna write the part 1. He's gonna write this in product form. Oswaldo is correct. It's 2.1 times 2.1. We already know how to multiply decimals. We could do this the easy way. 21, because we moved our decimals over, we move it back. Lucy, what is our answer? 4.414 and 41 hundredths. Fernando's gonna solve E. So Fernando is correct. Now, I want you to go to page 436. We're doing numbers 1 through 6. Before you move on to your homework, you must show me that you finished in class. Okay. Homework is page 437, numbers 1 through 10. On the back side, you're going to do 11 through 13. For 15, all you're going to do is complete the chart and do D. Really, super easy.